Hi everyone, my name is J. Harikrishnan. I am Assistant Professor at University. In the last session, we have discussed deadlocks, one of the topic in operating systems. In that topic, we discuss what is deadlock and deadlock characteristics. In this session, we are discussing the next topic, methods of handling deadlocks. So in the last class, we discussed the topic of characteristics. In that we are having mainly mutual exclusion, golden weight, low friction, and circularity. So in the next, now continuing the topic, we are having methods for handling of deadlock. So when deadlock occurs, the operating system will be handled by three methods and three ways. Here we are having the three methods. The first one is using the protocol to prevent or avoid deadlocks. And the second method is it will be allowing to enter deadlock state. Then it will be detect and recovering the mechanism. In the third one, we can ignore the problem altogether and pretend that deadlocks never occurs. For the first point, to prevent or avoiding deadlocks, ensuring that the system will never enter the deadlock state. Because of this is, we can take as an example, if we are getting fever, means thinking at that time, we are taking some precautions to avoid or to don't want to suffer with fever, we are taking some precautions. Like that only, this method, prevent and avoiding of deadlocks, will be work same like that. Through these methods, we can not enter into the deadlock state. If the deadlock state is occurred, the second step, it will be comes to the scene. Here, that system will be entering into the deadlock. After that, it will be detecting and recovering the problem. So to ensure that the deadlocks will be never occur, sometimes will be happen. So here now we are discussing the first point, prevent and avoiding the deadlocks. The system can use either a deadlock prevention or avoidance or a scheme of deadlock. Deadlock prevention provides a set of methods for ensuring that at least one of the necessary conditions cannot hold. These methods prevent deadlocks by containing how requests for resources can be made. Deadlock avoidance requires that the operating system can be given in advance additional information concerning which resources the process will request and use during its lifetime. With this, it will be decided for each request whether or not the process should wait. To decide whether the current request can be satisfied or must the process should be wait. That sometimes it will be deciding the current request may not be satisfied or delayed. The system will be considering the resources, what are the currently available or currently allocated for each process. And the future request also releases of each process. If a system does not employ either a deadlock prevention or a deadlock avoidance, then a deadlock situation may not arise. That sometimes, if deadlock is occurred, the environment, the system can provide the algorithm that examines the state of the system to determining whether a deadlock has occurred and algorithm to recover from deadlock. In the absence of algorithm to detect and recover from the deadlocks, we may arrive at a situation in which the system is a deadlock state, yet has no way of recognizing what has happened. In this case, the undetected deadlock will result in deterioration of the system's performance because resources have been held by processes that cannot run, and because more and more processes as they make request for resources. So to do not enter into the deadlock condition, we are working mainly these methods, either prevent or avoiding of deadlocks, and otherwise, once if it is entered into the deadlock, it will be detect and recover. Rarely the third method, it should be comes. We can ignoring the problem altogether, pretend the deadlocks never occur in the system. Now we are discussing about prevention of deadlocks. So how we can process do not enter the system into the deadlock state. One of the mechanism is deadlock prevention. It will be depending on the 4 characteristics of deadlock state. So in this, the 4 characteristics, this already we have discussed in the last session. The first one is mutual exclusion. Second one is hold and wait. The third one is no preemption. And fourth one is circular wait. So in this, any one of the process, if we solve or we can not enter into the state, automatically the deadlock will not occur. So first one, the mutual exclusion, the condition must hold a non-shareable resources. For example, the printer cannot be simultaneously shared by several processes. So shareable resources, in contrast, do not require mutually exclusive access and thus cannot be involved in deadlock. So through this mechanism, it will be not possible to avoid the deadlock. So in this case, we can't avoid any deadlock situation. And now, next, we are discussing the hold and wait. In this condition, it will be never occurs in the system. We must guarantee that whenever a process requests a resources or resource, it does not hold any other resource. Why? Because of hold and wait means it will be holding one resource and waiting for the another process resource. So if it is satisfied their own resource for another process, at that time, the deadlock state will never occur. That means if the work is completed of a particular process, the other process must be satisfied or need to sacrifice their resources to other process. At that time, another process will completing their execution, and then it will be releasing their resources for the next process. Based on that mechanism, this will be work. For example, when we need to differentiate based on two protocols, if we consider a process that copies data from a DVD drive to a file on disk, sorts, and then prints the results. If all resources must be requested at the beginning of the process, then the process must initially request the DVD drive, next disk file, and then print it. So according to that, the another resources will be available for the remaining process to execute their programs. Based on that condition, it will be satisfied. For this only, we are taking another example. If the process requests only DVD drive and a disk file, it copies from DVD drive to the disk and then releases both the DVD drive and the disk file. So at that time, the process must then again request the disk file and the printer. After copying the disk file to the printer, it releases those two resources and terminates the execution. Like this manner, the processes will be allocating their resources to sacrifice with other processes. Through that, it will be completing the execution. And next, no preemption. This is the third condition. If one of these conditions, it will be satisfied, then automatically deadlock will not occur into the state. For this, deadlocks, that there can be no preemption of resources that have already been allocated. To ensure that this condition does not hold, we can use the protocols. If the process holding some resources and request another resources, it cannot be immediately allocated to it. So no preemption means if the system by itself needs to sacrifice. So if we need a printout through the files, so first the process will be requesting the files, then that will be going for the print. Here, once the file will be taken printout from this mechanism, automatically it will be releasing the resource by the process. because of once this process is completed by automatically the resources will be terminating the place. And next, circular wait. This is fourth condition for the deadlock. Is one of the way to ensure that the condition never holds and to impose the total ordering of the all resource steps and to require that each process request resources in a increasing order of enumeration. Same, this one also will be looking like hold and wait mechanism. Circular wait means the processes will be allied on the circle if the first process will be depending on the second process resources and the second process will be depending on the third process resources and the third one will be depending on the fourth one resources and the fourth one will be comes again depending on the first process resources. In this, any one of the process will be sacrifice their resources. The second and third and fourth one completing their execution. And automatically, if their execution is completed, the resources will be comes free and that should be executing with the remaining processes. So this is in these four mechanisms, the first one, mutual exclusion, will not work to do not enter into the deadlock state. The remaining three, it will be helpful for do not enter the deadlock state. The first one only will be not possible or to prevent the deadlock state. The remaining three, it will be satisfying the deadlock conditions. So through the mechanism of deadlock handling methods, it will be solved. So what is basically we are defining means if in these four methods, any one of the mechanism is satisfied, the deadlock will not occur into the system. So the first one only, it will be not work and the remaining three will be avoiding the preventing the deadlock mechanism. And the next state is deadlock avoidance. The same whatever deadlock prevention is work, the deadlock avoidance also will be preventing means protecting before attacking the or entering into the state of deadlock. Here the deadlock avoidance, how it will be work means, for example, if a system with one file and one printer, the system might need to know that process request first on the file and then it will be goes to the printer. Releasing both resources whereas process is completed. And the next process, if request first per personal system means first printer and then the file mechanism. So with this competitive sequences of request and releasing for each process. So here the deadlock avoidance will be following two types of mechanism. One is safe state algorithm and another one is Banker's algorithm. So in this session, we are discussing about only safe state algorithm. The bankers algorithm will be discussing in the next session. So here, the safe state algorithm is state which is safe if the system can allocate resources to each process in order and still avoid a deadlock. More formally, a system is in a safe state only. If there exists a sequence of processes is a safe sequence manner. For example, P is a requested to some currently working by the satisfying the another process things. In this situation, the resources of first process needs not immediately available, then wait until the P2 process have finished their process. When they have finished and then obtain all of its needs resources to complete the designated task, returns its allocated resources and then terminates. So based on this flow of movement, most of the deadlock will not going for unsafe state. So once the state, if a safe state is not a deadlock, conversely, a deadlock state is an unsafe state. So means if programs are completed with a sequence of any issues, no issues, it will be going for a safe state. If problems are arise, that will be going to unsafe state. Through this diagram, we can define that one. Here, now the programs or processes will be shared their resources in a sequence. So that will be satisfying their conditions. Based on that, it will be in a safe state. The another one is the process will be raised problems with the other processes. So automatically, it will be enter into the deadlock state. We consider a system with some drives and three processes like P0, P1, and P2. Process first one, it requires the remaining types of the mechanism, and the second process may need the remaining same type of resources, and third process if need more than the first and second. At that time, it will be processing and holding only some resources for the first resource, and the remaining will be holding by the second resource, and last ones, how many is available, that will be allocating to the last resource. So based on this, if it is satisfies a safe state condition, it will be allocating the mechanism. Here, the first process can immediately be allocated all its resources and return them the process second one, that automatically completing their resources, and the second one should be completing the program execution, and it will be allocating to the third project. Like that, it will be completing the process. So for this, Here we are giving a representation of resource allocation graph through this mechanism, how the allocation graphs will be worked to process their resources. Here in the last session, in the resource allocation graphs, we have discussed one point, that is, if arrow is indicating from process to resource, it is request edge, and if resource onwards, if it will be allocated to the process, that is allocated edge. But here, if we see, it will be showing a dotted line, means requested edge, or we can, sorry, it will be a claim edge, and this will be allocated edge. Claim edge means the resources is need for both processes. So at that time, when if it will be sacrifice this resource, then it will be completing the program or process one. If claim edge is converting to the request edge, similarly, when a resource is released by the program or process, the assignment edge will be reconverted to a claim edge. We note that resources must be claimed a prior in the system. The before process is started executing. All its claim edges must be already appear in the resource allocation graph. For example, means if you are seeing this diagram, the P1 or process 1 is not defined that, so automatically the resource will be allocated to the process P2. Means here whatever the claim edge, it will be approached from process P2. So that will be get as a request edge. Now, if the process P2 is completed their execution, then it will be releasing the resource R2, and it will be acquired by the process P1. So, in this manner, we can consider the above resource allocation graph that P2 request R2, although R2 is currently free or allocated, we cannot allocate to P2. Since this action, it will be create a cycle in a graph. Mention indicates that system is an unsafe state. So that's it for today's lecture or session. So once again, what we discussed in this session will be repeating. So the first, it will be methods for handling of deadlock. There are 3 ways. That is prevent or avoiding deadlocks. And second state is once if the deadlock is in a state of manner, so it will be detecting and recovering the. And the third one is ignoring the problem altogether and pretend the deadlocks never occur. And in deadlock prevention, whatever the points we mentioned through the 3 mechanisms, the first point is deadlock prevention and avoidance. So deadlock prevention and avoidance will be used to diagnose before the problem will occur. Based on that, these two mechanisms will not, the deadlock will not occur into a state. So here, deadlock prevention will be depending on the four characteristics of deadlock mechanism: mutual exclusion, hold and wait, no preemption, and circular wait. The mutual exclusion only it will be not satisfying the condition. So based on this mechanism, the deadlock will comes. But the remaining three, it will be holding the deadlock process. So through these three mechanisms, we can handle the deadlock situation. So what is basically it will be defined means from any one of the characteristic, it will be solve or can hold the deadlock. So automatically the system will not enter into the deadlock state. And the next concept is the deadlock avoidance we have discussed. Here, the safe state algorithm and Banker's algorithm. The safe state algorithm will be executed in a order, in a sequence order. Means process 1 needs some resources. So process 2 will be allocating their resources to the team. So in order of based on protocol, it will be sequentially completing their execution process. At that time, through this diagram, the safe state will be saying the deadlock will not occur. The unsafe state will be dissolved. The deadlock will be occur. And in the safe state algorithm, the second mechanism is resource allocation graph. So through these two diagrams, we can understanding what mechanism will be gives a deadlock state and what will be used not entering into deadlock. So that's all. Thank you. We'll meet again in next session. Thank you. Thank you, everyone.